Today we're going to be looking at section 2 of chapter 7, which deals with similar polygons. So in your interactive notebook, you have a similar polygons flip book that we will be working in. The objective today is to identify and apply similar polygons. So we're going to take what we learned in section 1, okay, that idea of working with ratios, how to solve proportions, as we look at these similar polygons. So when you open up your scale factor flap, up at the top, we need to write in that definition for common ratio.
What is that?
It means Joe.
So when we are looking for the scale factor of similar polygons, we are going to be looking for that common ratio, which is the ratio of the lengths of two corresponding sides. So in our previous unit, we talked about what it means for sides and angles to be corresponding. So we're going to be taking two polygons. We're going to then make a ratio of a pair of corresponding sides to be able to find the scale factor. In these first two problems that you see in this section, they're just, again, problems similar to what we were doing in section 1. So number 1 says the lengths of the sides of a triangle are in the ratio 3 to 5 to 7. Its perimeter is 45 centimeters. Find the length of the longest side. So what's my equation I'm going to set up to work this problem? 3x plus 5x plus 7x equals 45. Okay, because we're talking about perimeter, we find perimeter by adding the three sides together. So when I simplify, I get 15x equal to 45, which means x is equal to 3. They want me to find the length of the longest side, which is going to be that 7x. So 7 times 3 is 21, and we are working in centimeters. Okay, so as we work with these different unit measures, very important that you are labeling. Number 2 says the measures of the angles in a triangle are in the ratios of 1 to 2 to 3. Find the measure of the smallest angle. So what's going to be my formula for this one, or equation?
1x plus 2x plus 3x equals 45.
No.
180.
Angles in a triangle
180.
add up to equal 180.
We get 6x
6x.
equals 180. And 30. X equals 30.
Mhm. And then we want the smallest angle. So our smallest angle is 30 degrees.
Okay. That's pretty small.
Okay. So now working this with this idea of scale factor. Okay. First of all, when I look at these two polygons, okay, I can tell by looking those polygons are not congruent. They are not the same size. Okay. They are what we call similar. And when you see this squiggle, we see that above an equal sign for congruent. When we see just that squiggle without the equal, it means similar. So I know these two polygons, these two quadrilaterals are similar, and I want to find the scale factor. So our definition said it's the ratio of the lengths of two corresponding sides. So you can choose any pair of corresponding sides because we know they're similar. That scale factor is always going to be the same. So again, it's important to find those matching pieces. If I look at AB, which is 10, and that matches up then with EF, which is 5. Okay, 10 over 5 simplifies to the number 2. If I were to take B and C, which is 8, that corresponds with F and G, which is 4. 8 over 4 simplifies to 2. If I took the last two, C and D, CD is 6, GH is 3, 6 over 3 simplifies to 2. If I took the first and last, AD is 5, would match up with EH, which is 2.5, which simplifies to 2. Okay. So again, as long as you are taking one pair of corresponding sides, you can find the scale factor because we knew they were similar. We were told they're similar, which means their scale factor is always going to be the same. Okay, so knowing they were similar, I would have only had to show one pair. Again, order is important when you do scale factor. The first shape, they want the scale factor of quadrilateral ABCD. So ABCD, numbers from this shape on the left, has to be in the numerator. The second one goes in the denominator. Okay? So again, scale factor, order is important. This second piece here, B, we are not going to be looking at those pieces, just looking at the individual scale factors. So if you take a look then at the next flap, okay, corresponding angles up at the top. Corresponding angles are, you need to fill in that word congruent. Even though we are talking about similar polygons, okay, they're not the same size, their corresponding angles are still congruent. Because when you, again, think about angles, no matter how big or small the triangle is, those angles are always going to add up to 180. Okay, the angle size does not change if you shrink or enlarge a polygon. Okay. So again, even though when I look at these two triangles, triangle ABC and triangle DEF, we are told they are similar. And if they are similar polygons, their angles are going to be congruent. So, what is the size of angle A? What?
82.
Angle A corresponds with angle D. Because angle D is 82, angle A is also 82. What is the size of angle E? 38. E corresponds with B. So F would be 60 because 3 angles in a triangle add up to 180. So what do we know about angle C? It would also be 60. Okay. So even though we're talking about similar polygons, the corresponding angles are still congruent. So when I look at this picture, number 2 says to find the value of each variable. I have both an x and a y that I need to figure out. So let's start with the x. Doesn't really matter which one. Okay, so I find x in this angle E. So which angle corresponds with angle E? E corresponds with R. You need to look at your similarity statement. Okay. So our equation is going to be x plus 34 equals 97. So I subtract 34, x equals 63. When I am looking to find y is angle T, which corresponds with F. So 3y minus 13 equals 98. So I add 13. 3y equals 111. Y equals 37. Okay, so they're just asking for the value of the variable. If they asked for the measure of the angle, then I would need to plug it back in. Number 3, we have 2 triangles. Again, we know the triangles are similar, which means their corresponding angles are congruent. I look for x first. What angle corresponds with K? Middle one, which is y. So 4x plus 3 equals 71. So I subtract 3. 4x equals 68. Divide by 4. X is equal to 17. And then I need to find angle y, which is angle J. What corresponds with angle J? Angle W. So y equals 45. So even though our polygons are a different size, because they are similar, the corresponding angles are going to be congruent. Now we move to corresponding sides. Okay? Corresponding sides are not going to be congruent. Corresponding sides are proportional. Okay? Corresponding sides are proportional. We know they're not the same length. We can see that because one of them's smaller than the other. So looking at this first diagram, okay, they've marked the angles so we know which angles are congruent, which then helps us as we match up those corresponding sides. So first of all, it wants us to find the scale factor of this one on the left, VUTSR, to EDCBA. So again, we can choose any pair of corresponding sides. When I look at this picture on the left, there is only one side that I have a number for that doesn't have a variable. It's this side of length 18, which is ST. So ST corresponds with BC. So my scale factor, 18/4, or we could say 18/4, okay? But that needs to be simplified. So it reduces or simplifies to 9/2. So that is my scale factor of these similar polygons. Okay. So now I need to find X and find Y. So to do that, I have to set up a proportion because my sides are proportional. Proportions, we know, are two fractions equal to each other. So for one of the fractions, we use the scale factor, which is 9/2. For the other fraction, we need to set up a ratio for a pair of corresponding sides. So I'm looking for X. Okay. X is side RV, which is first and last. So that corresponds with AE, which is 3. Again, order matters. Okay? We do the one on the left first because that's the one that corresponds with that 9 from my scale factor. So I'm going to have X over 3. So now I need to solve my proportion. So I'm going to cross multiply. 2x equals 27. So x equals 27/2. Okay. And here we're talking about a side length. Okay, so we don't want to leave it as 27/2. What is 27 divided by 2? 13.5 or 13.5. Okay? So because we're talking about the length of a side, we're not going to leave it as that improper fraction. I'm going to do a similar process to find y. So again, we start out with that scale factor of 9/2. To find y, y is in this side UT. UT are the second and third letters, so that corresponds with DC, which is 5. So y plus 2/5. Now I can cross multiply. When I cross multiply, I need to distribute 2 times y and 2 times 2, which is 4, equals 9 times 5 is 45. So I'm going to subtract 4. 2y equals 41. Divide by 2. So half of 41 is 20.5 or 20.5. So our corresponding sides are proportional. Okay, so we need to find a scale factor, use that scale factor to set up proportions. Okay? But again, order is very important as we look at those, matching up those corresponding parts. Next problem says, if triangle ABC is similar to triangle DEF, and AB is 5, BC is 6, AC is 7, and DE is 3, find the perimeter of triangle DEF. So I am going to draw two triangles. So ABC, AB is 5, BC is 6, AC is 7. And then my other triangle is going to be a little bit smaller, DEF. So we know DE is 3. Okay. I want to find the perimeter of the smaller triangle, which means I need to find the other two sides first. So similar to what we did in the previous problem, because I can just call then EF, I'm going to call that one X, and call DF Y, because I need to have those two sides before I can find the perimeter. So just like we did in problem 1, first thing we need to do is find the scale factor. So DE is the only thing I have in the small triangle. DE matches up with AB. So my scale factor is going to be 5 over 3. So now I use that scale factor to find X. Okay. So the scale factor 5 over 3 is going to be this X, which is EF, which matches up with BC. So it's going to be 6 over 3, or I'm sorry, 6 over X. Okay, 6 over X. So I cross multiply. 5X equals 18. So X is 18 thirds, which becomes 5 and, nope, I'm sorry, it becomes 6. Goes in the, no, let's try that again. 18 divided by 5, not 3. 18 divided by 5, so 5 goes into 18 3 times, with 3 left over. So you can leave it as 3 3/5. This does become a decimal, 3.6 inches. So you could write it either way because it is an ending decimal. Okay, so that's our X. Now we need to do the same thing for Y. So we use our scale factor, 5 over 3 equals 7 over Y. So cross multiply, 5Y equals 21. Divide by 5, 21 fifths becomes 4 1/5, which is 4.2 as a decimal. Okay. So if your fraction is an ending decimal, you can use decimals. If it's a non-ending decimal, we have to leave it in that fraction form. So my X is 3.6, my Y is 4.2. They want me to find the perimeter. So I have to add my 3 sides together. So my perimeter is 10.8 inches. So again, our corresponding sides are proportional. So we find the scale factor to use as we set up our proportions for those sides. Number 3, same kind of thing. They've given us the pictures, and we have that similarity statement so we can match up those corresponding parts. So when we look here, okay, we typically start out with a scale factor. Okay. Scale factor, we just have to match up any 2 pairs of corresponding sides. What we have here, though, is both of the sides in our smaller quadrilateral have the variable. So we're going to be able to set up a scale factor. It's just not going to be in numeric form. So if I start with mn, which is 3x minus 1, what does that correspond with in my second quadrilateral? LM,
Oh, I think you said MN.
or I'm sorry, MN. MN is RS. RS is 4. So 3x minus 1 over 4 is the scale factor. Cannot simplify it. That's okay because I have to set up a proportion that is equal to 8x minus 1 over, that matches up with ST, which is 12. So I have a proportion. I'm going to cross multiply. When I do so, I have to distribute. Okay, so if I take 4 times 8x minus 1, I get 32x minus 4 equals 36x minus 12. I have to make sure I distribute. So when I solve, I'm going to get rid of 32x, so subtract it, which leaves me with 4x. I'm going to add 12, which gives me 8. So 4x equals 8, which means x is equal to 2. Number 4, I need to find y. So I'm starting with this bigger one on the left. So y plus 1 corresponds with which one on the other polygon? JK, which is 8, equals 3y plus 1, which corresponds with LM, which is 20. So again, when I cross multiply, I need to distribute. So I have 20y plus 20 equals 24y plus 8. Then I want to solve. So I'm going to get rid of the 20y's. So I subtract, and I'm left with 4, which means I'm going to get rid of 8. So I subtract 8 from 20, which gives me 12. So y is equal to 3. So again, corresponding sides are proportional. So we set up a proportion, cross multiply to solve. Okay. So similar polygons. Corresponding angles are congruent. Corresponding sides are proportional.